How much ice conditions and wind strength influence sailing angles and sailing distance? And what is the difference to sail 2 kilometers race course on black ice and sticky ice? Let's find out. I've been recording my sailing tracks for several years now, and it's time to share with you a diagram of two extreme race courses for better understanding of sailing angles. This diagram represents close to perfect sailing race course on black ice and medium to strong breeze. We have two marks, wind direction and race course axis. For easier understanding, we set a race distance between marks at 100 units, or in other words, race course length equal to 100 units. In these perfect conditions, lowest upwind sailing angle recorded with optimal VMG was 45 degrees. We have one tack and two legs. At 45 degrees angle, each leg distance equals 71 units. After rounding the mark, iceboat starts to sail at even smaller angle of 33 degrees. We have one jibe and two legs. At 33 degrees, each leg distance equals to 60 units. Four legs combined make a lap distance of 262 units. Divided by the racecourse length, we get a lap factor of 2.62. And if the race is 3 laps, then the perfect race factor is 7.68. This means if the race course is 2000 meters, perfect race distance would be 2000 multiplied by 7.68, which is over 15 kilometers sailed. Now moving on to second example. This is not what iceboaters love most: sticky ice and light breeze. Survival mode. You can easily see the difference in shape of the diamond. Again, two marks, wind direction and racecourse axis, and racecourse length of 100 units. In these conditions, upwind sailing angle is really big and can reach 59 degrees. That translates into single upwind leg distance equal to 97 units, almost as much as the racecourse length. The downwind angle is reduced to 47 degrees, and notice that it is more than upwind angle in previous diagram. At 47 degrees, each downwind leg adds 71 units of distance sailed. Four legs combined make a lap distance of 340 units. Divided by the racecourse length, we get lap factor of 3.4. And if the race is 3 laps, then perfect race factor is 10.2. This means if the racecourse is 2000 meters, perfect race distance would be 2000 multiplied by 10.2, which is over 20 kilometers sailed. And short comparison of two diagrams. Sticky ice increases upwind sailing distance sailed by 36% and downwind distance by over 20%. As consequence, single lap and 3 lap race factor are 30% more. With usual 2 kilometers race course distance, a perfect ice would produce 15 kilometers race and sticky ice over 20 kilometers race. Similar to 1 mile course, over 20 miles on black ice and over 16 miles in sticky ice. But there are a couple of things to remember. You never get perfect race course. Rounding the marks is where you could make additional distance, wind shifts, and you make sailing errors. All that combined could increase your distance sailed by 15 to 20%. This could be especially interesting for everyone responsible for setting up a race course on a small lake or sailing area limited by all kinds of obstacles and cracks. Let's analyze most common racecourse length of 1 mile or 1.6 kilometer. The diagram shows sticky conditions. Area required for comfortable sailing need to include a fact that approximately 100 meters below leeward mark we have a starting line. If we have 50 boats on the line, we need roughly 500 meters long starting line, 250 meters each way. Now the real width of the racecourse is determined by the sailors starting to either end of the line. In this example, blue line represents first upwind. If we measure the distance between the spots where they have to tack, we get the estimated width of the racecourse. In sticky ice and 50 boats, it is 2,500 meters or 1.55 mile. That is 160% of the racecourse length, or factor 1.6. As ice and wind conditions get better, this factor will be lowered to reach the value close to 1. Of course, following laps will match closely dotted green line. This simple racecourse geometry guideline should be used by the race committee to assess optimal racecourse length in challenging ice conditions. I wonder, what are the angles for faster ice boats? Let me know in the comments if there is any data on that. See you on the ice.